Welcome to the Elmvale Water Festival. We're here today to celebrate water. This is the purpose of the Water Festival, is to celebrate our water resources. And this logo is our symbol for the Elmvale Water Festival. And it represents our aquifer, our beautiful water resources, and the flow are the artesian flows that we have so many of in this area. So I want to just take a few minutes this morning to explain why a water festival and why to do this in Elmvale. And also a few words about the Elmvale Foundation. This is the symbol for the Elmvale Foundation. It represents both the elm tree but also water, which makes this area so special. So it's the Elmvale Foundation that's putting on the Water Festival today. And the Elmvale's a non-profit organization. I'll say more about that at the end. Okay, so if we stand back and think for a minute about our water resources, if we stand back and look at the big picture, looking at water resources on the planet, we're all familiar with the hydrologic cycle. The point about water is it doesn't sit around. It's not static. Water is always on the move, evaporating from the ocean, going into the atmosphere, condensing, falling as rain, moving through the soil, and eventually return back to the ocean. Okay, and this cycle is very important because this is what connects all of the components of the surface of the earth. If we think about the oceans, 97% of the water is in the ocean. So 90% of the water on the surface of the earth is salty. The other 2% is frozen in the polar ice caps. So if we think about the oceans and the polar regions together, that's 99% of our water resources is either salty or frozen and unavailable for our use. And all of our other water ecosystems, all of our lakes, our rivers, our streams, all of that together is less than 1% of the total amount of water that we have. And if we start by looking at the oceans, it's important to realize that the oceans are alive. These organisms here, foraminifera, they build their shells using calcium carbonate. So I want you to go home with the picture of the oceans being alive, full of life. And these organisms, their shells made of calcium carbonate, when they build these shells, they're removing carbon dioxide from the atmosphere. Okay, so these organisms are like a kind of biological pump removing carbon dioxide from the atmosphere. So this is the carbon cycle, and I won't go into all the details, but what I want you to notice is the surface layer of the ocean is hugely important in regulating the amount of carbon dioxide in the atmosphere. Why is that important? Well, we've been adding carbon dioxide at quite a rate. This is a graph which shows the amount of fossil fuels that we've been burning since the Industrial Revolution. So we're emitting massive amounts of carbon dioxide to the atmosphere. And what is the significance of that? When carbon dioxide dissolves in water, it will make the water a little bit more acidic. And we now have evidence that the acidity of the oceans is starting to change, and that's affecting the ability of these organisms to remove carbon dioxide from the atmosphere. So not only are we adding carbon dioxide to the atmosphere, but by doing that, we're affecting the abilities of the oceans to remove it from the atmosphere. And this is one reason Bill McKibben wrote this book, The End of Nature. In the old days, we could move to an area, we could destroy it, and then move on to another area. We can't do that with our atmosphere. There's only one. And affecting the atmosphere by emitting carbon dioxide on the scale that we're emitting it is affecting global climate. Okay? And the extent to which global climate will be affected, we'll be seeing that in the coming years. So again, 97% of our water in the oceans. What about our ice caps? 2% of the water in the ice caps. Well, the planet is getting warmer. If we look at this graph over the past 150 years average annual temperature, you can see that the past few decades were much warmer. So our planet is getting warmer, and we know that. And we know it's because of these greenhouse gases that we're emitting. Carbon dioxide is one of the most important ones. It's not the only one. but they form a layer in the atmosphere which traps heat and makes our planet warmer. Okay, what is the significance of that? Well, it means that our ice caps are melting. And the ice caps are melting at a much faster rate than expected, because what we didn't anticipate, when the ice melts, there's giant lakes that are forming. And whereas ice will reflect the energy from the sun, the water will absorb it. And cracks form. And when these cracks form, that accelerates the destruction of the ice caps. So the ice caps are melting much, much faster than we had anticipated. Okay? Now many people would say, okay, who cares? It means we'll have less polar bears, so what? It's not as simple as that. This conveyor belt, this is our ocean current system. This is the biggest driver of the Earth's climate system. And as the ice caps melt, they add huge amounts of fresh water to our oceans. It's cold, it's dense, and it sinks, and it's beginning to affect this conveyor belt. We have the first evidence now that the Gulf Stream is starting to slow down. Okay? So it's ironic that as the planet gets warmer, places like Newfoundland and Great Britain may actually be colder, because we're slowly shutting off the Gulf Stream. Okay, so 99% of our water is either salty or frozen, and all the rest of it accounts for only 1% of our water resources. Now you might say we have tremendous water resources here in Canada. We have beautiful rivers. Here's the St. John River in New Brunswick. And we have tremendous lakes. This is Georgian Bay, Algonquin Park, in the Rocky Mountains. Those are beautiful lakes. Notice how different each one is. They're completely independent ecosystems. And we look at those and we say our waters are pristine. They're beautiful in the day and they're beautiful at night. But we're emitting all kinds of contaminants to the atmosphere that's affecting our lakes. Okay, and one reason why Peter Dillon is here today, he's one of the world's leading authorities on the effects of atmospheric change on our lake ecosystems. So there are many, many threats to our lake ecosystems. There are many parts of the world that don't have enough water. This is Los Angeles, which is essentially a desert, and water has to be brought in here. If we look at the major river systems of the world, many of them are under threat because of overuse by agriculture and industry. And this is very nicely summarized in this book by Fred Pierce, When the World Rivers Run Dry. And Ron Martin is here to tell us about the situation with water in Australia for people to realize what it's like in areas that don't have enough water. And you might say Canada's very different, but in fact, most Canadians live in the southern part of the country, where in some areas water is more limited. Many municipalities in Canada have also faced water shortages. The prairies have experienced record droughts in recent years. In Vancouver, restrictions placed on watering lawns. So as we affect the global climate system, we're affecting the entire water cycle. And we don't know quite how all this is going to work out. Another issue with water today is arsenic. Arsenic in groundwater, and there are many, many countries in the world that have too much arsenic in their groundwater. This causes skin cancer. Bangladesh is one of the worst. This has nothing to do with pollution. This is nature. What about our wetlands? Wetlands are very important habitat for many animals and very many plants. An example of a beautiful wetland, the Wye Marsh, which is just up the road from us here, and they're going to have an educational display here today about the Wye Marsh. These have a very important effect on regulating our surface waters, and they're being drained and they're being destroyed, and we're losing our wetlands worldwide at an incredible rate. James Lovelock published a book a number of years ago, Gaia, about the Earth and how it functions as an organism, and what scientists have realized during the past 20 years is that all of these various components of the environment are all connected to one another. And he's also written in his most recent book the implications of global climate change for our society. Ice cores are incredible archives of a climate change. So if you want to understand how our planet is changing, we can take cores of ice and study those. And when we started looking at ice cores, we were really surprised to find that during the past decades, the amount of antimony contamination in the Arctic atmosphere, very remote, is actually on the increase. Now you're going to ask yourself, what is antimony? Well, antimony is a metal, much like lead, and it's a potentially toxic metal. It's been used to get rid of unwanted people in the past. It's also used to make plastic water bottles. So polyethylene terephthalate, or PET, is made using antimony as a catalyst, and the plastic water bottles actually contain antimony. So I got really curious about the water in this area and how much antimony it might contain. And as you all know, this area has abundant artesian flows where water is literally bubbling out of the ground. And we found that this water has 2 parts per trillion of antimony. So this is an amazingly low concentration of antimony. It's so low that most labs in the world can't measure it. Well, why is that relevant? If we look at bottled waters, and we've looked at 132 brands of bottled water from 28 countries, here is our local groundwater with 2 parts per trillion, and we notice the bottled waters have up to 2,000 parts per trillion of antimony. So it leaches out of the bottles from the plastic. And the longer the water sits in the plastic, the more antimony the water will contain. Now these concentrations are below the drinking water standards, but antimony is an element that our bodies don't require. It has no physiological function. It's not like calcium or magnesium, so it can't be beneficial at any concentration. So we all know that water is the source of life, and we know that in the Elmvale area we have abundant artesian flows, and that's an opportunity to celebrate, and that's why we're here today. So the purpose of the Elmvale Water Festival, first, to raise public awareness about the main issues and to improve the general level of understanding. What we want people is to better understand water, but also to celebrate our precious water resources. How many villages in the world have beautiful water bubbling out of the ground like this? Okay, the Elmvale Foundation, you've heard me talk about it. It's federally incorporated. It's a nonprofit organization. I created it earlier this year. In fact, it was conceived in January. The board of directors assembled in February. It was announced at the town hall meeting in March. We incorporated in April, and I guess about two weeks ago we received our charitable status. So it's not only a nonprofit organization, it's a charitable foundation, and it's the Elmvale Foundation that's putting on the Elmvale Water Festival today. The purpose of the foundation: environmental science education, research, and teaching. And as Chris said, we protect what we value what we understand. So we've got beautiful water resources in this area. If we understand them, I think we're more motivated to protect them. But those water resources are also an opportunity to educate people about the environment. And that's the purpose of the foundation. There's more information at elmvale.org. So I want you to have a great day and enjoy the festival, and thanks very much for your attention.